Okay, and finally, the people who are watching this online, can they confirm that the video is good? Yes, good. Go ahead.
Yeah, the topic of today's talk is concerns finitely generated subgroups of three groups. So in this talk, F will be always in a free group, and also you can, for all purposes, you can assume that it's finitely generated. So we will consider finitely generated subgroup of three group, and we will study the notions. We say that H is compressed. In F, if the rank of H is less than equal to the rank of T for every number F, we contain P, which contains H, and we say that H is inert. Similar to quality false if for any subgroup T of F, the intersection, the rank in the intersection of T is more than. So it's clear that inert implies that the theorem will not represent it, but in fact, not unequal.
To be clear, the rank is the number of each.
Yes, rank is the number of this number of so in three group. So this solves the question of conjecture. Well, this in 96. So later I will explain the motivation. I want to start explaining and modify these properties and the consequences, some consequences of this. So the notion to be compressed is a very natural notion. Let's say that rank over any over subgroup can be larger, it can be smaller, cannot be smaller than rank of the subgroup. And in fact, we can check this property algorithm. I will now explain an algorithm how given a subgroup or given a subset, finite subset. Finite subset of free group, how to decide where the zero group is going. So what you can do, you just construct what's known by starting core of the group. You can consider the Schreier graph. Consider the Schreier graph. It's generated by a finite set X. So we Let's consider the Schreier graph. Three sets of generators. Three sets of generators. Now this Schreier graph looks like there's some core, and then you have a lot of things. And now what's that? Now we eliminate all the trees and look at this. Core graph. So we understand this is a core graph because it's not only a graph, but it comes with a special vertex. So this is a graph. This is a labeled graph. And now its graph with a special vertex. In this case, it's the graph vertex. Example, I take the subgroup generated by these two elements. We produce a graph. There's no vertex. Fundamental group of this graph is exactly age. And also from this graph, you can read three sets of generators. It's not always these two words. Normally you start with these two words and then you do some kind of style folding, produce graph, which is your graph, fundamental group, this graph, this group. So this gives us a construction of styles and injection in the finely generated subgroup. Okay. X and one graph. Or graph. So this is a standard way to study subgroups of the group. So study this graphs, you can obtain a lot of information about subgroups.
But this special vertex represents the identity of
Yes,
the group,
that
right?
is.
But
Very
then,
class of the identity.
but then, why does it necessarily belong to the core? Can it be in one of those branches?
Okay, you construct the, okay, yeah, I don't eliminate this. Yeah, I don't eliminate this. Yeah, I want, not, yeah, basically, yeah, I need to calculate the generators.
Well, you could if you want, because inert and compressed are both well defined up to conjugacy.
Yeah, but this will be different. If we really want to see our group and not this group of conjugation, I want to mark the point where I will start reading. Yeah. Yes. Okay, so for example, we can read from this graph whether there is subgroup is complex or not. So in order to do this, let's define another notion. So we say that algebraic extension. So we have two subgroups. open bracket extension subgroups if H is not in a proper department. And we can consider this set, the set of the extensions. Automatic extensions of a given subgroup H, and we have the following effect. That's the following effect. So if A is belongs, A is the algebraic extension of H, then its score graph, the score graph corresponding to A is a coordinate. For graph. And this immediately gives us two consequences. Those consequences, this set is finite.
What is exactly the quotient of the graph?
Okay, quotient.
You identify.
Yeah, you identify some, identify some edges, some vertices, and some edges.
And then corresponding
Yes.
edges. Mhm.
So in particular, this set is finite. And okay, you can, there is an algorithm.
The quotient is the morphism of graphs, right?
Yeah.
Okay. One, two.
Yeah, that's on.
But morphism, like normal morphism graphs. Mhm.
And there is an algorithm that calculates. Question? Numerator. Not all quotients will correspond to algebraic extensions. And in particular, of course, it's H is compressed. You can only if this inequality holds for subgroups which algebraic extension. So really, this inequality has only on algebraic extension. So in particular, you can algorithmically calculate with the number inside. Find a subset. Generates compressed sum.
Can you give an example of an algebraic extension which is infinite index?
Take any two generated subgroup and two generated free. No. Yeah. You cannot. And the three factors. So it's algebraic if H is not in a proper three factor.
Ah, oh yes. Mhm.
Any three factor of two generated subgroup will be cyclic. So if you take so, for example, this is compressed subgroups. You can somehow, given set of generators, decide whether this subgroup is compressed. But the question is it true that the intersection the complex subgroups and already this natural question cannot be answered in using this representation, using representation tableau. It's broken. However, if we consider inner groups, inner subgroups, let's look these two questions for inner subgroups. Inner subgroups. This question is clearly the positive answer of H. We start with two subgroups in A and consider any subgroup. Okay, then when we start to calculate in there, first we can do it first using the H2 is one of the this is
Ни хера не видно.
it's inequality and using the H1 is one of yeah. With not necessarily H2. So, for complex subgroups, this question quite complicated, but for inert subgroups, it's always directly from the indication. And on the other hand, if you try to construct an algorithm to decide whether a subgroup is inert, it's okay. Not know how you can do it looking in the diagrams of the sub. So we see that we have these two related notions, but in some sense they are similar because the properties of intersection, but on the other hand, they're quite different because some questions are easy for one of them and difficult for others. So this, because of this, people were not sure what is the real answer on this conjecture. For some people, the inert groups are, complex groups are also inert, also that's surprise. So as I said, compressed subgroups are very natural notion, but inert subgroups appear in different contexts. It was in this book of Higgs and Ventura. And this was related to so-called the equalizer conjecture. Another question about subgroups of free groups. So assume we have again free group F, and now consider two endomorphisms. So we can associate with this endomorphism a subgroup, which is called equalizer. So the definition is the points of F. So I said it's endomorphism after the same way. And in general, it's easy to construct endomorphism where this group is infinitely generated, F is finitely generated. So, but if you assume that one of them is injective, you are right. No one's equalizer. It's conjecture. Sometimes it's attributed to Stein. Stein did not formulate it in this way, but he formulated a particular question related to this conjecture. It says that if one of them is injective, then the run the equalizer is and there is quite a lot of work with conjecture. So the most famous is the result of discrete Handel. So we consider the case when both endomorphisms are automorphisms. The paper, yes, native, was published in 1992, and it was, this case was generalized to the case when one of them is authority. This appeared in 89, but this is that use. They published it. This paper was available. So, Dixon and Ventura realized the following property of the equalizer. So assume we start subgroup. And consider an embedding property F and K. Fix any embedding context. Now we can consider the equalizer of the following composition. We start with restriction phi on K, and then apply alpha. And then we apply the restriction. And the second one is start with restriction of psi and apply. So in doing this, we obtain two endomorphisms of K. And so equalizer conjecture implies that this should be at least the rank of K, but of course this is calculated, not more than take the original equalizer subgroup and concept. So it means that equalizer conjecture is the following form, different form. So you can formulate it and change this by the condition that this was how the motivation for this property. They realized that in fact it implies more. Like the condition implies not that the rank of the equalizer is at least the rank of M, but it implies that the equalizer subgroup should be. And in this case, so the case when both automatism was confirmed by this Ventura paper, I mentioned already, 96. And in the case of one of these is automatism, done by myself. So it's important to notice that this reduction, which changes these two statements are equivalent, only if we assume this or the validity of all equalizer conjunction, not only this particular case. So there is no equivalence between these two statements if only for this case. We need really the full statement. So, and in this paper, we introduced a new notion that will be important for this talk. So, use a new notion which define, gave the name to this notion L2 independent example. So today I will not explain this definition of L2 independent. I will define a related, more algebraic notion because I work in three groups and I can define it in different ways. Maybe Olga will define it. I don't know. Okay. Yeah. So, to motivate this notion, let's consider another situation for models. I fix from now on, I fix field K. And as before, have a free group. It's a free group. And I want to consider three models over KF. Left, I will consider the left model, left. So there is a fact which similar that any subgroup of free group is free. There is a fact that any submodel of free model. So I can now define the notion of compressed in terms of free models. I say M, the submodel, finally generate. Finally generated. A model. We say M is compressed. And submodel. And this rank effect. So again, the rank means the number of elements in a basis, so free model has a basis. Here, also can, the number of elements in each basis has the same size. And so we can speak about the rank of field. So it's looks like similar notion, but because we are working in this context, in more algebraic context, here there is a nice characterization of this problem. Characterization, so there is a division ring. Okay. Size Z. M is compressed. And the natural map. So we have a map from M to N, then we extend the starlights. Then we extend the scalars and we still have the injected map. And this property also can be characterized in a homological way. It's a calculation of torque, and to calculate torque one means that this torque is so this analog of compressed submodel but leads us to some homological condition, which in many occasions easy to check, because this is some kind of calculation with torque. A lot of tools, some tools to manage calculation. So now this leads us to definition for subgroups. How we start, we can back into this equation. And this gives us following two three models. Find this. So this guy is the augmentation idea. Map of the theory, the journey of this map, and this guy is the left submodel. With the augmentation idea of the related one. Okay, this one is free. So it's free. And its rank as a free KF model is the same as the rank of F as a group. And this guy is also free. And this rank. So if we want to study ranks, we don't lose this information. It's and of course, it's clear now. This definition, I hope it's clear. Yeah. No, I find it. I need to write one definition. So now I define what I mean by independent. So now I say that H is independent. F if this model is complex. Now, I hope it's clear that that means definition. Because what if we have any subgroup, within H and F, we can produce corresponding containment for model. And the reverse of this formula. They decay independent imply that H is complex. But what is in fact true, this is slightly more difficult. In fact, it's true that with this property, it implies, this was basically observed by our this was also okay. Also what we have is that for any prime E, we have that if we're independent, so that is here. Is equivalent to and two independent, which we did not define, but which appears now for Louisiana, and as I said, it's a more Louisiana and the last implication is that prime E also has consider F independent. This implies there is a way to show that the independence of the characteristic P is stronger than the zero. So if I presume this, then the following chain implications but much chain of implications. We have P prime. So as I said, it's implied two independence independent characteristics here. This is the same like as independent. This implies no. This implies some. And the conjecture but all the notions are equivalent. All these five notions are. And what I was able to prove is that the conjecture holds. And because it holds for p equal to, in particular, you obtain the okay, so I have 3 minutes. Yeah, maybe in the 3 minutes that I have, I will explain what is the property of people to G importantly. So the proof is of course technical, but there is one point where this property appears, and I cannot substitute at this moment by another argument. And the property is the following. So consider this model. Logically, we see it as left model. Now we want to understand the submodels of index 2. So we want to consider submodel. Like that, this quotient harmonic over x2, and with action, when the action of f is trivial. And it turns out that because p is equal to, that we can describe this model. Now, if, this is subgroup you effect of index 2 such that so in some sense, there is a subgroup which is associated to this submodel. And in the proof, so we use a kind of induction. This really plays an important role because in some moment we can find some subgroup of how this compressed property, use compressed property. This
Questions or comments?
So about the top implication, DFPP and DQF independence. So can you just focus on that? For example, if you know it in characteristic 0, then it will hold in almost every prime P.
no, this is
Yeah, but in the other direction.
another direction. Okay, yeah, of course. Because, basically, here you have already all these are equal. So
Yes.
now we already know, this is, we know, because if I put two there, we know already this and this. Yeah, so if you,
Yes, but if you want to,
if you want to, yeah, it's enough to put this.
yes, but does it hold for almost every prime?
This is a question, yes, probably yes, I was.
You would
thinking about
expect
it,
that,
but,
that at worst there are only like some.
Yeah, almost always for fixed stage.
Yes.
This is the problem, so it's not really very exciting. If you fixate,
You do mean if you fix stage.
okay, this is the property of H. So for the subgroup H of F, these three, this five notions are equal.
But the implication for D, FP, F independent implies characteristic zero independent. This is true for modules in general.
This one.
Yes, it's not just for
No,
modules that come
okay,
from.
For models, in this case, you have to compare, you have to start with this models of ZF. Yeah, it must be then to start model of ZF. Yeah, and then you have two types of models, DPI and then you can define. Speak about equivalence. Of course, it's not equivalent, but yeah, but more or less, you're right.
Another question is, or could you please zoom out now? Sorry, zoom out. Yes. Can you do the same thing for surface groups?
Not. Yeah, but it's probably
Probably it's even more complicated to classify submodules.
Please, I'm going to ask for which groups in principle one can expect something with compressed and your subgroups.
Yeah, but first you have to define what is compressed. Yeah, because of course, like for surface groups, of course, you can speak about run and yeah. In general, you have to define because it's not about ranks already. It's maybe a very characteristic. But okay, maybe for failure characteristic for limit groups. It should be.
And simply for rank as a number of generators, it doesn't.
No, it's already, no, of course, rank, it's not good parameter already.
But is it always something if you take some other groups and simply speak about number of generators and compressed and not in this sense, it never works out.
Okay, for surface, it's still maybe okay. Yeah, it's still okay, but for say 3 by z squared.
See, the number of generators is not such a good kind of parameter,
No.
right, topologically.
For
It's
example,
really-
for example, z squared.
But
Z squared is not. Yeah, but yeah, it's.
no, I understand maybe it's not the best notion of rank, but even in this context, I wonder if for some groups one can expect that compressed and inert will be the same for all subgroups.
Yeah, maybe it's not.
So perhaps for free products of finite groups. Then you
Yeah.
have all the Grushko theory that should be almost as easy as free groups.
Yeah. But,
Well, a generator for the two counts as half a generator and so on. Yes. Have to build them weights.
yeah, okay, virtual. So earlier characteristic is getting variance for this kind. There you can also do earlier characteristic.
In this notion of algebraic, like, so if you take intersection of two algebraic subgroups, it doesn't have to be algebraic.
It's algebraic extension.
Algebraic extension, I understand, yeah, so not transcendental in the sense that it is not a free product like this.
Yeah, two intersection.
Then an intersection of two algebraic.
I would
Whatever.
maybe.
Because at some point you said that it does not work, like if you, the methods like of taking a product of graphs
No, yeah, what I said that it's difficult to see from studying score whether the subgroup is or not. Yeah. So for intersection, how, yeah, so the previous, so for example, Kahneman conjecture, yeah, it's also about intersection. You study the rank of intersection using the product of graphs. And you know that it's not enough to obtain the best bound. Yeah, this is the problem. And here you really need the best bound. Not like you need, it's not enough to have a constant. Yeah, so you cannot see it from the code.
If there are no further questions,
Thanks a lot.
and we have a small break until 3.